Hey, hello everyone. I guess you can see me and you can hear me well. I don't have access to the chat, but I am gonna assume that everything is going well. So yeah, my name is Alvaro Navarro. I am developer advocate at Vonage. I'm part of the developer relations teams, and welcome to this webinar. And the topic for today is stopping fraud before it happens. So yeah, let's have a look to the agenda, to the menu that we have for today. So I'm gonna do a super quick intro to Vonage, to the company, and then we are gonna be covering the challenges that the financial services are facing today. Then we will talk about the APIs, the solutions that we offer at Vonage to solve all these challenges and problems. And then we are gonna do a demo, which will take most of the time of the webinar. Okay, so let's start with a quick introduction to Vonage. So what is Vonage? So Vonage is an end-to-end communication provider, and since 2022 we have been part of Ericsson. So our business is built around two main areas, as you can see here on the slide. So first, we have the unified communications and contact center, where we offer solutions that help companies to improve the way they communicate and engage with customers. And the second is our API business, which includes traditional communication APIs like video, voice, messaging, and also the new collection of what we call the network APIs or network power APIs. These APIs allow developers to access and integrate mobile network capabilities directly from the mobile operators on their applications. In today's webinar, we will focus on two of those network APIs, Identity Insights, which provides information and intelligence about the phone number. We will cover that in a moment. And Verify, which enables two-factor authentication through different channels. So just a few numbers about us. We are present in more than 100 countries, serving APIs and solutions to more than 100,000 customers, with a global developer community of 1.6 million. Just to name a few customers, we have Lydia, Revolut, Garmin, Vintage, and a few others. Moving on to the second part of the webinar, let's understand a bit better what kind of challenges the financial services are facing today. So today, financial services and financial companies are facing a wave of fast-changing threats. That means that threats are becoming smarter and harder to detect. For example, we have account takeover, where attackers use phishing kits or SIM swap services to break into banking or gaming or social media accounts. And they do it sometimes in minutes, which is super, super scary. So we also have what is called authorized push payment scams, where victims are tricked into sending money into scammers. Like, for example, you hear a fake voice or you see a spoof phone numbers. And under these scenarios, scams usually pretend to be experts in, investment, purchases, or even impersonating someone you love, right? We have another situation like attack the synthetic identities, where criminals mix personal data like a real ID number with fake numbers, phone numbers, or emails. And they use these fake profiles to get, for example, loans or claim bonuses for promotions. So yeah, that's a problem, because imagine the situation where your bank is asked you to return money that you didn't actually request, right? That's scary. And finally, artificially inflated traffic, right? Fraudsters send floods of fake one-time password requests, sometimes to make money, test stolen credentials, or slow down competitors. So yeah, as you can see, all these attacks show how creative fraud has become. And that's why we believe we need smarter ways to stop it and protect our users. And to make things even worse, online fraud has become industrialized. It's scary, but today almost anyone can become a fraudster. You don't need technical skills. You don't need to be like a super expert hacker anymore. So everything is available as a service. So there is this what we call fraud as a service, which is something that together with generative AI has dropped the cost of launching an attack to just a few cents. For example, you can clone someone's voice with, I don't know, $5 a month using online services. You can rent what is called the Evil Proxy, which is a full phishing platform for about $100 a month, or even buy a drag and drop phishing kit for $25, completed with a 24/7 customer support, which is absolutely crazy. For the price of something between $300 and $2,000 per SIM, you can even order a SIM swap from a service provider. It's as simple as that. And so we are not just dealing with individual hackers anymore. So we are facing a fraud industry built to scale. What is the result of all of this? The result is that online fraud is exploding. That's not a surprise. It's estimated that this will cost around $10 trillion in 2025 to companies, and this is just the tip of the iceberg. Because first, we have what is called the fraud multiplier. For example, in 2023, for every dollar lost to fraud, U.S. financial institutions spent $4.40 more on recovery, chargebacks, fines, and operations. But it's not only about money; it's about trust. About 70% of customers say that they will switch banks if they felt their money is not protected correctly. And finally, we have the missed revenue, billions lost every year because users abandon signups or drop their cards when the experience feels slow or too complicated. So yeah, beyond that money, fraud also damages trust, loyalty, and growth. And three things that no business can afford to lose. Yeah, but there is good news because we can actually stop fraud before it happens by using advanced capabilities from the mobile network itself. This is what we call the network power fraud protection, which is a new way of detect risk and verify users in real time directly through the mobile data. It's fast, it's silenced, and it's incredibly hard for attackers or scammers to fake. And we are going to see a demo in a moment. And how do we do this? We stop fraud across the entire user journey, from the account creation on the left of the slide to customer engagement, right? So just to mention a few examples, we can help during the account creation phase. So we can verify that the user identity. We can verify the user's identity automatically and confirm that they really own the phone number that they are using. Another example is when users want to recover an account because, I don't know, they forgot the password. We can perform an invisible SIM swap check to confirm that the phone number has not been associated with a new SIM card recently, and we prevent that way the SIM swap attack. And finally, in customer engagement, every message sent can be branded and verified using things like RCS, making phishing and spoofing almost impossible. So that's the challenges that we believe the financial industries are facing today. As you can see, some of them are super scary and super easy to exploit. So let's see what kind of API, what kind of solution we can provide from Vonage to protect our business and our users. So today we're gonna we will be focused on two APIs. So the first one is Verify API. Is our network power omnichannel two-factor authentication solution. And when I talk about omnichannel, I mean that the API supports different channels to verify users. SMS, I'm sure you know, you have used that in the past. RCS, the new standard that is will eventually replace SMS. We have voice, and we have silent authentication. And as we will see in a moment, the cool thing about this silent authentication channel is how the API verify users without friction using mobile data. So users don't have to enter OTP codes anymore because everything is done automatically behind the scenes. So the result of using silent authentication is super cool because it improves security and improves the user experience without compromising performance, which is super important in those scenarios, right? And the second API that we are going to be using today is Identity Insights API. That is an API that provides real-time network level intelligence to improve fraud detection and risk models. And how does it work? Well, the API receives a phone number and it returns insights like the number format, the origin, the original and current carrier, and also the SIM swap status, and together with timestamp and much more. We're gonna have a look to the documentation in a moment. And this is how the Vonage network APIs help fighting fraud and improve the authentication, which is basically the challenges and the potential situation that we have been talking before, and how our APIs are helping to avoid those situations. So, for example, for fake accounts, Verify can confirm that each new account is linked with a real and reachable phone number. And Identity Insights can block potential synthetic identity before they enter in the system. In order to, for example, for account takeovers, Cell Authentication remove OTPs to avoid the man-in-the-middle attack. And SIM swap helps to block recent SIM changes. They can be also used to prevent refund and promotion abuse by identifying virtual or fake numbers using during the sign-up process. And when it comes to artificially inflated traffic, using silent authentication and removing SMS reduce the risk. And Identity Insights can help us blocking fake accounts that could generate that traffic, right? And those APIs can even help us with regulatory pressure. For example, by meeting the PSD2 requirements through real-time SIM swap checks. And finally, they deliver a better user experience, of course, by verifying users silently in the background without extra steps. This is something that we discussed before. Okay, so now it's time to have a look to the APIs. This is the scenario that we are going to be showing today. So the idea is using both APIs to improve and increase the protection and reduce fraud in a mobile application. Let's say that we're a bank, we're a financial institution, and we have a mobile application. And by using Identity Insights and Verify, we want to increase the security of our users. So the idea is the following. So we have a user that wants to log into the system using the mobile app, and we are going to check that there was no SIM swap in the last few days by using Identity Insights API. Once we have the verification and the confirmation that there was no swap, we are going to go with the second step, authentication phase, and we're going to be using Verify together with the Cell Authentication channel to verify the identity of the user with the mobile data coming from the mobile phone. Once everything is okay, we have the final validation from the system, and we are good to go. We can proceed with the rest of the login process. Okay, so this is what we are gonna implement or show today. So before starting with the demo, let's have a look to the developer portal and see how the APIs are displayed on the portal. So in order to start with the to get started with our API, we should go to developers.vonage.com. This is the URL of our developer portal, and you will see here different categories, right? So Verify is under privacy and security. We scroll down here a little bit. You see here Verify API, and we can open documentation and API reference. I'm gonna open them in different tabs. This is the landing page of Verify. We have access to all the guides, tutorials, the references, everything that you need to integrate and get started with API is here, okay? An interesting thing for us is the API reference, where we can check all the endpoints exposed and used by the API. So here Verify use different endpoints. The first one is this endpoint. It's a post endpoint to request the verification that we are going to be sent to the user. Then once we start the verification, then we need to check the code that is coming from that verification, right? We can also cancel verification. We can go to the next workflow, something different scenario that we are not going to be covering today. But the important thing is this, that we are going to use those different endpoints, these first two endpoints, to verify, to start the verification, and to check the code coming from that verification. Also important when using that API is that we need to implement authentication, right? In this case, Verify supports both JWT and the basic authentication. In our case, we are going to use JWT. We will see that in a moment when we cover the dashboard, that we need the private key and the application ID to generate the token. But I'm going to be covering that in a moment. So important authentication. And another important thing is how the request for starting the verification looks like. So the request is a post, and we need to prepare this body. Okay. So yeah, if we are going to be using silent authentication, like in this example, silent authentication must be the first element in the workflow array. Okay, that is important. Then we can say, all right, so in case silent authentication doesn't work, maybe because the network is not the best in where the user is located, or there is a problem in the network, etc., we can switch to a different channel. In this case, we're going to be switching to SMS. And if for some reason SMS doesn't work, we can switch to a third channel. In this case, is voice. Okay. For the demo today, we are going to use silent authentication and SMS. And the rest of the body is basically defining how we want to proceed with all these channels. We can say, okay, send the SMS using this local, this language, the channel timeout before switching between different channels. What is the brand? Which is basically a way to identify ourselves. And something more advanced, like in case you want to use template for your SMS, you can do so by using different endpoints. But for this demo, we are gonna keep it simple. We are gonna use silent authentication and SMS as a failover channel. Okay. Basically, that's everything that I wanted to cover for the request, and then the response is gonna be something like that. We are gonna get the request ID, and we are gonna get the check URL. I'm gonna cover in a moment what is this check URL about. But one of the important things about Verify is that Verify use an asynchronous behavior. That means that whenever we interact with the API, we're going to receive callbacks to our backend with changes. And for example, if we specify that we want to use silent authentication and something happens, maybe silent authentication didn't work, we are going to get a callback saying, hey, silent authentication didn't work. We are switching or failing over to SMS. All right. So all these events, all these changes in the workflow will be received using callbacks. That is important because now when we cover the dashboard, we are going to see how to set up the way we are going to receive those callbacks. All right. So as a recap, important thing about Verify, we can define different workflows by using this workflow array. We need to implement authentication in the API, and we are gonna, the API works in a synchronous way, so we need to implement a way to receive those callbacks in our backend, all right? So these are the three important things about Verify. Cool. Then let's have a look to the other API. We go back to the developer portal. We can go to network features, and one of these APIs is identity insights. Again, we have the documentation, and we have the API reference. The documentation covers basically all the insights that the API supports. So if we come here, we can see a list of the existing supported insights. And the rest of the insights in a developer preview. Developer preview means that the insight is implemented in the API, but it's not yet ready for production. Okay, so we have it here. It's fantastic for developers because they can test it, they can provide feedback, but it's not yet ready for production. All right. So which insights we have today that can be used in production? We have format, which is validating the phone numbers format. It's going to provide information about the prefix, the country, etc. original carrier and current carrier, information about the network that was initially assigned to that phone number. And in case you are changing the company, is providing the information about the current carrier, okay? SIM swap, which is providing information about when was the last time the phone number was paired or was linked with a new SIM card. And we get information about this SIM swap, whether it's a true or false or whatever, together with the timestamp, which is super interesting. The rest of the insights in developer preview are location verification to verify whether a location of an end user is within a specific area. We have subscriber match, which is basically comparing the end user data for a phone number with the with information that the operator has about this particular user. And we have roaming and reachability, which is giving information on where the user is located, whether they are in a different country, they are on roaming, they are on a local network, etc. Okay, so important thing here again is going to the API specification. So in case of identity insights, it's easy because it only exposes one endpoint. Is this one? It's identity insights, and is using a post request. Important thing, similar to verification, we need to remember that this API use authentication, JWT, so the same token we use in our backend for verify can be used for identity insights. And then we need to understand how to prepare the request, the post request used for getting all the insights. So, of course, first thing we need to do is send the phone number, and then a list of insights, all right? So each insight can be set with different parameters. For example, in case of format, it's not receiving any extra information in any extra parameter. But for SIM swap, we need to specify the period in hours of the maximum time that we want to check whether there was a SIM swap or not. In case of original and current carrier, no need to specify additional parameters. But for the rest of the developer preview insights, you can see here in the documentation all the potential, all the different parameters that we need to specify. Since we are not be using that for the demo, I'm going to skip that part, okay? But we are going to be focusing on SIM swap with the period in hours and the phone number. These are the interesting parameters for us. All right, cool. Now, we saw how the API works, what we need to do to integrate those APIs in our application, in our backend. Now, the second part is how to create an account here, right? So usually you will see here a button to sign up. In my case, you don't see it because I already have an account. And I'm logging already. So if you click on the dashboard, this is the dashboard, right? So you here in the dashboard, is the part of the portal that you can control your configuration, your balance, your application, logs, analytics, etc. So the first thing we need to do is we go to applications, and here those applications are going to provide the credentials that we need in order to perform the API calls, right? So in order to create a new application, we click on here on this button. We can provide a name like my test application. And if you remember when we were talking about the authorization on verify and identity insight, we talk about JWT. So for JWT, we need the private key and we need application ID. So for the private key, we need to just click on this button, and it's automatically generating the private key. It's here on my computer already. This is the public key. And then we need the application ID. That the application ID will come after we click on generate new application. Super important. In order to use the network APIs, we need to switch on this toggle here, this capability, the network registry capability. And we're going to see something interesting here. We see the playground and production. These are the two different environments where the APIs can operate. Production, as you can imagine, is production, is live data, etc. Network APIs are meant to be used by companies, not all individuals. And in order to get access to those APIs, you need to go through the Vonage network registry, right? So this registry, this network registry is a process of requesting access to the network APIs. So it's taking a while. I don't know why it's loading slow. I think it's problem with my network. But anyway, so the network registry is a way of allowing people to request access to the network API. So they can create a business profile, they can expose their business case, the use case where they want to use the APIs, etc. Right? That application, that submission will go through Vonage and the rest of the mobile operators, and everyone has to agree and has give permissions in order to get access to the network APIs. Good thing is, as soon as you get one approval, you can start using the APIs for that particular mobile operator. So this is the network registry. So you have to click on add business profile and then follow the rest of the process. Which countries I want to operate in, etc., etc. Okay. The second environment is the playground. The playground is a safe and controlled environment where I can start using the APIs without production data. The interesting part of the playground is that we can use the playground in two different ways. If we click here on, if we go back and we click on playground, we can use the API using two different phone numbers. The first one is what is called the allow list number. So basically what we do is, okay, so I own a phone number that I want to use for within the playground. I can click on add number, the prefix and the phone number, etc. And the user, in this case is my phone, will receive an SMS to confirm that I want to be part of this playground. So once you accept and you verify that you want to be part of the playground, you can use that phone number within the playground, right? That's super interesting because you can start integrating the API with real data only for that phone number. If you try with a different phone number, the API is gonna return an error. So you make sure that you are on a safe and controlled environment, working only with your phone number. The second thing you can do, if you don't, for example, you are in a country which is not supported by the network APIs, is using what we call the virtual operator. The virtual operator is a global fake operator using a +990 prefix. And it's basically returning fake static responses, right? So good thing about the virtual operator is it's working globally. You don't need to be in a specific location or country. And it's supported by all the APIs, right? So if you want to understand how the APIs behaves and without spending money, in this case, you can use the virtual operator. Here on this list, you see the list of operators and countries supported by the sandbox. All right. So let's say you are in Germany and you have a Vodafone phone number that you want to use for your test using the playground. You can come here. You can add it to your allow list here by clicking on add number, and you are good to go. Okay. So here you see my phone number that I use for testing. And this is the phone number that we're going to be using during the demo today. All right, so once we specify here that we are going to be using the playground for today, we need to switch on silent authentication. And here we need to enter a URL. If you remember before, I said that verify works in asynchronously, and we need to specify somehow where do we want to receive all the callbacks. This is the URL that our backend will receive the callbacks. So you have different possibilities. If you are testing, you can deploy your backend somewhere on the internet in a public URL, or you can work locally and use one of these tunnel tools like ngrok or Pingy, etc. So this is actually what we are going to be doing today. So so here's the place for entering the callback. So I'm gonna use in this case I'm gonna use localhost, but it's just to call back. Once we are ready, we can click on generate new application, and here we have the application ID. The private key is already on my computer, so I could be ready. I am ready at this point to start doing my test. Okay. All right. So I already have an application here, the Network APIs demo, with the application ID, with the configuration already in place. So what we are gonna do is I'm gonna share the screen of my mobile phone, and before that, let's go back quickly to the presentation. So I want to show you how the demo works. Let me see, because this is not working on the full screen is not working anymore. But anyway, okay. So this is what we are gonna be representing today. So we have the mobile application and we have our backend, what is represented here as an app application backend. And on the right side of the screen, we have Vonage. So the first step is to trigger the verification, start the verification process. So basically what we are gonna be doing is we have a mobile application with a button, login button, and the user is going to click on that button, and then it's going to start the verification process. So what we are going to be doing is sending the phone number after the user clicks on that button. The backend is receiving that phone number, and we are going to be calling identity insights to check that there was no SIM swap in the last 3 days. Okay. The API will return true or false. And if we return false, we are good to go, because that means that there was no SIM swap in the last few days. Once we make sure that the phone number has not been compromised, we can start the verification. Next step is performing the call, the post request to verify. And verify will return the callback saying, hey, this is okay, or it's not okay because there was a problem, right? But the callback will contain the check URL. And the check URL is super important. Why? Because we need to return that URL to the mobile application. And this is when it comes to the second part. We need to send that check URL from the mobile application. This is the way we have this is the way we implement verification from the mobile application. So we are sending this URL, we are performing a request to that URL, which is like a challenge response situation. We send that URL from the mobile application. That URL will go through different redirects, because it goes to Vonage, it goes to the mobile provider. The mobile provider is going to return, yes, this is fine, this is not fine, etc. And finally, we are going to return in the last step the request ID, the original the request ID that we have been using through the whole process, together with the code. And this is the code we are going to use in the second endpoint of verify, right? Which is the last. Let me move this here. This is the last part of the verification process. Once we receive the code coming from the API, from the first verify call, we need to call verify together with the code to get the completed, the okay or error response from Vonage. Okay. And we are going to be performing those API calls from the backend, from our backend. Okay. So in a nutshell, we need 3 steps. We need to trigger a verification. Verification is going to return the check URL at some point via callback. We're going to get that check URL, and we are sending that URL from the mobile phone. And finally, we are verifying that code from our backend. Okay, so these are the 3 steps that we need to implement to integrate, verify, and identity insights. Okay. Cool. Then let me share my mobile screen. All right. So I think you can see. Yeah, you see here the backend. So this terminal here is representing the backend. I have my tunnel here running, and I'm gonna start my my backend here is listening on incoming petitions on port 4000. So all that my tunnel is basically connecting an external URL to with this localhost port 4000. And then I'm going to start the mobile application. You see here my phone screen. This is the fake application that we are pretending to log into the system, right? So we have here already the phone number ready. And then what we're going to do is going to click on login, and we will see here all the different messages coming and sending in and out from the backend. So if I click on login, first thing we are calling identity insights, is verifying everything. Let's go back from the beginning. So first thing we are doing here, we are calling identity insights, the phone number, and the SIM swap insight. This is the response. Okay, the SIM swap happened in 2024. There was no swap in this period of time, so it's okay. All right. Once we verify that my mobile phone has not been compromised, we can call verify. And then for verify, we send the verify post request using the phone number. And this is the response coming from verify. We get it here synchronously and using the via callback, as we mentioned before, right? So this is the check URL that we are sending to the mobile application. The mobile application is performing a GET request to this URL. And finally, the mobile app is getting the code and sending the code to the backend. We check the code for this request, and we get the final result from the backend say, hey, this has been completed. Cool thing about verify is that all the callbacks contain the status of the workflow. So whenever something happened, like, I don't know, verify didn't work or couldn't be completed, and we are switching to SMS, etc., all these different events will be received through the callbacks, okay? And this is super interesting because that allows us to implement different behaviors depending on the current status of the request, okay? So let's try something different. Let's let's switch off data, and I'm leaving Wi-Fi on. So in this case, I'm gonna restart the app. I'm gonna click on login, and what's gonna happen is that silent authentication failed because I disabled mobile data. And then I'm switching to SMS, right? So now the situation is this one. Silent authentication didn't work, and now we are going to SMS, okay? For some reason, the API didn't allow me to switch to SMS. So I'm going to restart this. I'm going to restart this. Maybe it was a problem with my network. I'm going to try again. Oh, okay. So this is a problem when you are implementing, when you are trying to verify a user, but you didn't finish the previous request, right? So you get a 409 error conflict, right? So you need to wait until the timeout comes, all right? So in the meantime, let's have a look to the code of the backend. So for the backend, I'm using the Node SDK, which is fantastic because I'm receiving the SMS now. It's really good because it's basically abstracting and isolating all the complexity of implementing the authorization and everything, all the API calls, by using a very easy to use interface. So we have 3 different packages here for authorization, for verify, and for identity insights. So basically what we need to do is instantiate this auth object with the credentials, the application ID, and the private key coming from the environment variables. And then the backend is gonna expose different endpoints to the mobile application. In this case, what it is to implement verification, to start the verification, the first part of the process, if you remember the diagram. And then we have the callback. This is the callback that we are setting on the dashboard for receiving all the callbacks. And finally, the check code, which is basically the endpoint which implements the second or the third part of the verification process using verify, right? So in the first part, when we are verifying, this is the way we called identity insight. Super simple. We have the client here, and we have the method get identity insights with the parameters. The parameters is basically the body request, as we saw on the API reference documentation. Once we make sure that there was no SIM swap detected, we can start with verify to process. So here, this is the call to verify with the brand, the workflow, self-authentication, SMS, etc. So after different redirects, the mobile application will receive the code, and the mobile application will call check code with the code here and the request ID in order to perform the check code method call to verify the final result of the verification, right? So this is the backend. Not very complicated. I mean, it's quite simple using the Node SDK. Let's try again super quickly the situation where we don't have mobile data, only Wi-Fi. Let's see. All right. Okay, so cool. In this case, we are receiving this problem because the verification didn't finish before. But yeah, okay. So something we can do also is switch on the data, and we can try with different phone numbers, so you can see the behavior of the playground. So instead of 3, I'm going to put 4, which is not my phone number. I can click on login, and here you see that verify is returning an error, right? Well, first of all, identity insights is returning an error, and then the callback is returning this fail because this is not my phone number, okay? So yeah, this is another situation where we can switch to SMS, etc. And also something we can do is we can use the sandbox with the virtual operator. Now, if I restart the application, something I have to do is removing the second channel because the virtual operator does not work with SMS. So you cannot receive an SMS on this fake phone number, of course. So I need to remove the second channel. I start the server again, and then the situation is that if we go back to the documentation here on verify, you see how it works. It's on the here, virtual operator. So this is the documentation for virtual operator, and the way it behaves is depending on how the number ends. Is even or odd, the API will return true or false. Okay, so this is interesting because you can test different scenarios with these fake numbers. Now, if I click on login, this is an invalid phone number. I think probably I missed one number. Oops. Give me a second. I think okay, so let's try with this one, for example. Oops. And let's restart the application. Let's put this number here. We click on login. Okay, and then we are getting the verification okay, because this is this ends with 2 and is supposed to return true in the verification in the verification API call. Okay, so this is another way of using verify, integrating verify using the virtual operator. And yeah, so this is basically what I have for today. This is a link to the in case you want to follow us on different social media. So feel free to drop me a question if you have any. I will be happy to answer them. Cool. Okay, so we also have a link here on the chat in case you want to create a developer account with an extra credit. You have the link on the chat. Unfortunately, I don't have access to the chat, so I don't see anything. Probably, Rachel, if you see any question, let me know. Otherwise, I think we can finish the webinar. Okay, no questions. Cool. Thank you everyone for attending, and feel free to reach out to us if you have any question. Thank you. Have a good day. Ciao.